Okay, so how are we going to do this one? Well, let's read it through. An investor has found two investments, yeah, there's supposed to be a plural there, that he wants to invest in. The first one pays 8% per year, and a more risky investment, 23% per year. Wow, that's big bucks. He has 41,000 to invest and would like an annual income of 8,080 bucks per year from his investments. How much should he invest at each rate? From the words, write two equations with two letters. Then solve the system of two equations using matrices, inverse matrices on T84. I wrote or Desmos. I think I changed it to GeoGebra. Any of those are fine. Doesn't matter. Desmos, GeoGebra. It will be much easier than the traditional methods of substitution or elimination, right? Okay, let's do it. So we need two equations. Well, let's call this one X and this one Y, right? X is the amount here, Y is the amount there. All right, well, the first equation, and we have two letters, you know we need two equations. So the first one is X plus Y. The first one is just total dollars. X plus Y equals 41,000, right? Because he has 41,000 to invest. So the amount invested at 8% and the amount invested at 23%, they have to add up to be his whole $41,000, unless he just threw some in the trash, right? The two amounts have to add up to be the whole amount he invested, the whole 41,000. The second equation is interest. Dollars of interest. So how are we going to get dollars of interest? Well, this is an 8% account, so it's 0.08x. However much money X he invests in that account, he gets 8% of times that amount. 8% times X is what is the interest he's going to get, plus 23% on the Y account, and he wants his total interest to be 8,080 bucks. There's our two equations, two letters. Now you could solve it by hand if you want to. You could get X alone, plug into the other equation. That's fine. If you want to do the addition method or substitution, you could do that. But I'm going to do it with matrices. I'm just going to say, look, this is 1,1,1,0,8,23 times XY. You just put the XY in the front like that. You might wonder, where'd the XY come from? Don't worry about that. That's the form of the matrix equation, right? And then all we have to do is let this one be A and let this one be B, and then the answer XY will equal A inverse times B. Let me show you in the notes. That's right here in the notes. I called it solving a 3x3. Really, I'm doing it for a 2x2 here, but it's the same thing. Basically, when you have a big system, 3x3, 2x2, 4x4, whatever, you just let A be the left side, B be the right side, and then your answer is A inverse times B using technology. It's right in the notes. So we just go, oh, okay. So my answer is just going to be this inverse times B times the right side. So I just go to technology and put that stuff in, and it'll crank it out. This is easier than doing it by hand. So let's go to technology now. I will go to the TI calculator first off. All right, here we go. Go to second matrix, go over to edit A, hit enter. I'm putting in, now I'm going to go 2x2, 2, enter. Put in matrix A, which is 1, enter, 0.08, 0.08, enter, 0.23, enter. So every time you hit enter, it saved it. So it's got it all saved now, 11.0823. I'm going to go second, quit. It's got matrix A. Now go back into the matrix menu again. Go over to edit again, but this time go down to B. I'm editing. See how edit is highlighted and 2, which is B, is highlighted. Edit B, enter. Matrix B is a 2x1. 2, enter, 1, enter, goes down to, what is it? It's 41,000, 41,000. Don't put any commas in. Down. Oh, I should have done enter, huh? Enter, 41,000, enter. Wait, let me try that again. You're supposed to hit enter. 41,000, enter, and then 8,080, 8080, enter. So every time you hit enter, it saves the whole matrix. It's got matrix B saved now. Second, quit. Now you just call them forth to the main screen. Go to the second matrix, name A. It's on, right? Don't move over to edit. It's on name A. Enter, and then hit inverse, A inverse times, and then second matrix, go down to B. I'm going to name matrix B, enter, A inverse times B, enter. There it is, 9,000 in the first account, 32,000 in the second. 9 and 32. So there we go with the TI. Let me show you on GeoGebra. Here we are on GeoGebra. So you just say, all right, matrix A equals curly bracket. For matrix A is 1, 1, comma, curly bracket 0.08, comma 23. Oh, I mean 0.23, no. Comma, 0.23. So see what I got there? What did I do? I did something weird. There we go. So it's 1, 1 in the first curly bracket, and then 0.08, 0.23 in the second curly bracket, separated by comma, enter. Yep, there's matrix A. B is the column matrix, so it's matrix, and then matrix 41,000, right arrow, matrix 8080. So you have to put the numbers for B, each one in its own separate curly bracket. Why? Because they're each a row. You got to have them going down. They're each their own row. Enter. So there we go. Now A to the power, shift up arrow, shift 6, -1, A inverse, go right arrow, or tab, or click to the right, times B. A inverse times B. That's weird. It like rounded it. Did I put something in weird? Nope. So it's funny. Yeah. So that's really 32,000. It's funny how it looks like GeoGebra is having a little trouble getting the exact value here. It kind of rounded it wrong. That's an actual mistake. Technology is not perfect. That's a mistake in rounding. The answer is really 32,000. Funny, the TI calculator actually did better. 9,000 and 32,000. The TI got a perfect answer. So 9,000 and 32,000. So don't worry about that little rounding mistake. Just put in your answers as 9,000 and 32,000. And back to the main screen. So put in our answers, 9,000, 32. So that investor should invest $9,000 at 8% and $32,000 at 23% to get the kind of returns he wants to get on that. Again, you could have solved this by hand, right? You could have got X alone, move Y over here, be 41,000 minus Y, then plug that in for X right here and work out all the decimals. You get the same two answers. Technology is just a little nicer and quicker. Matrices. That's why they invented matrices, to make these kind of problems quicker and easier to solve. There we go.